Okay, today we're going to look at derivatives. Okay, guys? Definition of a derivative we've done, but we'll review it. We're going to learn about notation. And there's an alternate form for the definition of the derivative, which sometimes the algebra is easier with the alternate form. We're going to look at the relationships between the graphs of the function and its derivative. Okay, and graphing the derivative from data, and I'm even going to do the one-sided derivatives, and we should still have some time left at the end. What is the average rate of change? What is an average rate of change? It's the slope. What's the instantaneous rate of change? Okay, it's called a derivative, and it is the slope of the what? Slope of the tangent line. So all of this should be reviewed and maybe make things clearer, I would hope. So let's look at the average rate of change on this curve. Do you want to use C or do you want to use A? C.
I thought slope was the secant line.
That's right. Slope, and I'll actually put that in here, secant. Where the instantaneous is the slope of the tangent line. Okay, so we're going to go over some distance h, and our x values, you should be drawing this with me, will be c plus h. So if this is f of x, what's this ordered pair? C, f of c, and this is c plus h. Grant, what's this going to be? F of c plus h. And now I want the slope of the secant line. So it's just the slope. You'll be given an interval if they ask you for average rate of change. You're just going to find the slope. So the slope of the secant is equal to, that's the change in y over the change in x. So it's f of c plus h minus f of c all over c plus h minus c. I like to write it that way because I get to see slope. Change in y over change in x. So what about the tangent line? What's the only thing that's different? I'm going to take this point and I'm going to drag it down the curve. And what's going to happen? Wait a minute, what's it? H. H goes to 0, okay? So you have to be careful about that. You have to use the right, you can't use words like it. So the slope of the tangent line is equal to the limit as h goes to 0, and it's f of c plus h minus f of c all over, because that simplifies, to h. Now, I don't think you're going to have the definition of a derivative on the exam where you actually have to find the derivative that way. But what they'll do is give you a limit, and you're going to say, oh, that's a derivative, and you'll do it a different way, an easier way, which is what we'll be doing on Friday. So Friday tomorrow we're going to do 3-2, which is more of the same, but I believe it's with the physics. And then Friday it will be the rules for derivatives, which you're going to like. That's why there's a smiley face on the board. Okay? We remember this from last week, right? And there it is. Now, I got to emphasize some things here, though. It is the derivative of the function f with respect to x, because it's a rate of change. If I change on this curve my x value from right here just a little bit, what happens to the y value? It changes. Right, in this case it goes up, could go down. So when I talk about a derivative, I have to talk about the ratio of two changes. If I change x, what happens to the y value? If I have the volume, let's say I have a balloon and I'm blowing it up, and let's say it's a perfect sphere. Now the variables are different. I have the volume and I have the radius. What happens when I change the radius a little bit? If I put more air in, what happens to the volume? That increases. Okay? So you can't just talk about the change in the volume and stop. You have to talk about the change in the volume as the radius changes. That's going to be a critical idea as we go through this, well, as we go through the whole year, actually. So we have to be careful with that. It will take us time, and I will reinforce it over and over again.
What is, when you take a derivative with respect to y?
You can do the derivative of x with respect to y,
Yeah.
and we'll talk about the derivative of y with respect to y. We'll be doing all of that, but I don't want to do that today. Right now, just keep in mind that you're seeing how the y changes when you change x. That's way ahead. And the notation is f prime of x. Now notice, this is a derivative function. This is not at a single point. This is anywhere on x. Now, the other key thing here is the word differentiable. If the derivative exists, we say that that the function is differentiable. And that's important because that's what they're going to give you on the exam. They'll say, consider a function which is differentiable everywhere. And that tells you a lot. What does that mean? That means that the derivative exists. You can calculate the derivative. What happened when we had a sharp corner? What happened at this point? It doesn't exist because you can't find a single value for the slope. So that's the problem with the sharp corners. So if they say it's differentiable, it means it's always going to be smooth. No abrupt changes.
Is that an inflection point?
Well, not really because this doesn't have any concavity. But if I did this, then it would be an inflection point. Almost everything is going to be piecewise, to be honest with you. Nope, this is a nice polynomial. Okay, so when we say it's differentiable everywhere, we have a differentiable function. So let's do, really quick, let's remember how to do the derivative of x cubed. But I want to know specifically is what is the slope anywhere on the curve? And I know x cubed looks somewhat like that. Actually, let's get a better picture, because I know what happens at the origin. Okay, that's x cubed. And the slope is different here than it is right here. And it's different here, isn't it? So the slope actually is a function of where it is. And we're going to be doing some graphs of these. So now we're not talking about derivative of a point. We're talking about the derivative of the tangent line anywhere on the curve. So we have the derivative f prime of x is equal to the limit as h goes to 0. I'm going to write it again. It's f of x plus h minus f of x. You could do a c, it doesn't really matter, over h. And we had to do this on the lab, didn't we? So it's the limit as h goes to 0, and I'm going to substitute x plus h in for x. So it's x plus h cubed minus x cubed all over h. And if you put h equal to 0 in now, you get 0 over 0. So this tells me what to do. I can't think of anything to do except maybe why don't we just cube that out? If h is 0, then I am with x cubed minus x cubed. So that's the problem. And I don't really want to think about factoring that, actually. And I don't think it's going to work. So we're going to try a different trick. Let's just do what it says to do. Let's cube that. Now, do you remember how to cube that? It's x cubed. What's the next coefficient going to be? I know you know, 3. And the x's, exponents go down, x squared. The h's start going up. These exponents have to add up to 3. Plus 3, x's go down, h's go up. X's go away, and h's go to 3. And if you remember, I have always promised you that these terms are going to reduce. They're going to cancel out. And sure enough, x cubed goes with x cubed. And it gets kind of, to me, tedious now because they're all done the same way. What am I going to do next? Factor out a what? H. So it's the limit. I could divide. Personally, I like to do that. I'm going to pull out an h. I'm left with 3x squared plus 3xh plus h squared. Did I do that right? Can't pull another h because I don't have any more. Yes? Because of Pascal's triangle, the coefficients here are 1. This is for the squared, 1, 2, 1, and the cubing looks like this. If you did the fourth degree, it looks like this.
Don't figure that out. How could you
Pascal.
decide?
I can with a CAS calculator, it will cube it. You want to do expand. You have to have all your parentheses. I'll help you later. Okay, what happens to H's? They go away, right? They cancel out. You're left with ones. And now the hardest part of all is to do the calculus and substitute H equal to 0. What happens to these two terms? They're 0. So the answer is 3x squared. So my function was x cubed. Its derivative is 3x squared. And I'll give you another one just to tease you a little bit. If I give you f of x is equal to x to the fourth, does anybody know what its derivative is?
4x cubed plus.
4x cubed. No c's. It's only for integrals.
Oh.
It didn't do it. It says it's. Oh, what? It works. So 3x squared is right.
Right.
It works.
That's a function. So this is my, where's my cubic? And it says that the derivative is 3x squared, so the derivative of the cubic is going to look like this. And we could put it on our calculator if we wanted to and see it. We'll do that for the sine function. We could do it for this one too. Oh, I'm telling you it's 4x cubed. Friday you'll know where that comes from. Okay. There is another definition of a derivative. You can do it a different way, which actually is the same way, but the algebra ends up being a little bit different. So here's my function, and I'm now going to look at a point here, A, and now I'm going to look at this point, call it X. Then this ordered pair is A, f of A, and this is X, f of X. Can I find the derivative between those 2 points? Can I find the slope of the secant between those 2 points? Sure. It's f of x minus f of a over x minus a. And what I want to do is find the derivative, so it's the limit. It's not h now. This point's right here. What's happening to x? It's approaching what? A. So x approaches a. And in the homework, some of the problems use the first definition, and some of the problems will ask you to do this definition. The only difference is, because it really is exactly the same thing, is that the algebra tends to be different. So if I call this distance h, then what's x equal to? A plus h. So if I substitute that in there, and I substitute it in there, I will get the limit. I'll worry about that in a second, but it's f of x, which is a plus h, minus f of a over a plus h minus a. That's the same one, isn't it? Well, honestly, I like this alternate form because that's the one I used in physics all the time, and I can see slope there.
Okay, now I do square the x.
We're going to do that one. Now, what's happening here to the limit? If x is approaching a, what's happening to it? If x is coming down this curve approaching a, what's happening to h? It's going to 0. You do have to be careful with these limits and what you're operating with. It's the same thing. The algebra will be different. How will you use this on the exam? They may give you a limit that looks like this, and you're not going to calculate the limit. You're going to say, oh, that's the derivative of this function, and you're just going to do it an easy way, which we haven't done yet. So let's go ahead, and let's do the square root of x using the alternate definition. So it's the limit as x approaches a, and it's f of x minus f of a over x minus a. Okay, what's f of x? Oh, I should draw a picture of it. You guys know what it looks like, right? It looks like this. So it's the square root of x minus, what's f of a? Square root of a over x minus a. And remember, we did a few problems like this. Oh, they were numbers, but a is just a number. Do you remember what we had to do?
What's y times x minus a? Is that right?
Almost square root of x plus the square root of a. Do you remember when we did that?
Yeah.
That's why we did it. Now this is a trick. It's all this is. It's a math trick. If this didn't work, I'd have to try a different trick. Like a think one. Because the function was square root. Why do we have to multiply by the conjugate? Because it's f of x minus f of a. This is f of x, and this is f of a. And if I substitute in a, I get what? 0 over 0. Okay, so let's multiply that out. So limit, as x approaches a, what happens in the numerator? Square root of x times square root of x is x. The middle terms go away. It's minus square root of 8x, ax, and this is going to be plus square root of ax, so it's gone. And then it's minus a. And then you want to, but I'm going to tell you not to, multiply the denominator out. It's complicated, and we don't want to do that because we always want to have a multiplication problem when we reduce. And so what happens to x minus a's? I'm left with a 1. That's right. And I'm going to take the limit. I haven't quite gotten there yet. Now, this is almost a calculus. The only thing about calculus is the fact that it's going to be a limit, and then when I take the limit, that's the calculus. The rest is all algebra. Now, what are you going to put in for x? No. You're going to put in a, right? So it's 1 over the square root of a plus the square root of a. That is a fine answer. Nothing wrong with it. I can simplify it, but I want to make sure I'm going to do it right. So it's 1 over 2 times the square root of a. But both are correct. You will get full points with the first answer without simplifying. And to me, it's getting tedious because I've been doing it twice a day every day, but so I'm really good at it, right? Because I practiced a lot. Okay. Here's the notations for our derivatives.
And then we have a sheet like that.
Okay?
We have one of those sheets.
Yeah, it's right here. You just don't have the skeleton. Okay, this is y prime, or you could say f prime of x. You read it y prime. Over here, this is a little discussion on why we'd use a notation over another one. It's nice, it's brief. A lot of you will prefer to use y prime, which is fine, but it only gives me the one variable. Doesn't really tell me much. F prime of x gives me a little bit more information. This is the one that we're going to use the most often. It's Leibniz's notation. I think I'm spelling his name right. German mathematician, and he called this dy dx. That's how you say it. But it means a lot more than that. It does name the variables involved are y's and x's. So I could have a dv dr. Now the variables, I have the radius and I have the volume. That's how does the volume change if the radius changes. And I'll go over that a lot of times. So this is the one we're going to use all year. That's the most powerful one. And the same thing is this. This is a df dx. And it's really what it is. It's the derivative of my function with respect to x. And that's the part that you want to ignore that, but you really can't. It's the derivative of y with respect to x. That's the correct way to say it, but we do say dy dx. Honestly, the second and the third ones are the same. And here, in the last one, this is looking at a d dx as an operator. This says, find the derivative of my function with respect to x. It's an operation, like adding. Okay? But this is the one you're going to use the most, dy dx. And you use y prime also, because it's easy. Okay, that's the end of 3.1. Now,
That's totally fake. It's not a real word.
3.1, oh, that's the first half of it. Okay, so let's finish this off, and then tomorrow is a work day for you guys. We're going to look at the relationships between the graphs of a function and the derivative. Should be an f prime here. Maybe my pumpkin's in the way. No. Pumpkin pie. We're going to graph the function given the derivative. And when you actually collect data, you think about your data in your science classes, it's always a derivative. Population growth is how does population change over time. That's not the function. That's the derivative of the function. So you're always timing things in physics. So those are always derivatives. Okay. Relationships between the graphs. We're going to get our graphing calculator out in a second. But let's do this one by hand. Okay, guys? Ready? I'm going to make a little table of values to help us. Now, guys, this is f of x. This is the derivative of f of x. I want to graph the function. So what we're going to do is make a table of values. Our y values now are going to be the slopes. And all we have to do is estimate. So let's look at 0, 1, 1.5 is an important one, 2, 3, and 5. What's true about the slope here? It's what? It's almost a vertical line. It's really, really big. Okay, but it might be like 100. If you go over 1 and you go up 100, it's pretty much vertical. 100 is what your calculator gave you anyway on your lab, if you remember. How about at 1? What's the slope of the tangent line at 1? Looks like it's 1, doesn't it? Okay. What's the slope of the tangent line at 1.5? 0. Okay, guys in the back? So that we can actually look at the new function that's a derivative of the original function. I can find the slope of the tangent line anywhere on my curve. What about at 2? Looks like it's -1. At 3, it's getting steeper. -2? They're not going to be very big. And what happens back here again at 5? It's 0. And if the function is a nice smooth function like this one is, its derivative will be nice and smooth. So at 0, it's going to be a big number up here someplace. At 1, I'm going to be at 1. At 1.5, I'm going to be at 0. At 2, I'm going to be -1. Remember, these are the slopes. At 3, I'm going to be -2. And back at 5, I'm coming back to 0. So it's going to come down like this and come back up. It's going to be smooth. It's not going to have any sharp corners. As long as the original function was smooth. So you're going to do some of this. And tomorrow we're going to have an activity where you match the function and the derivatives. All I did was estimate the slopes. That's it. Is that okay? Three is -2, yes. So let's look at, can our graphing calculator do this? Yeah. Let's look at y1. What's the derivative of the sine function? Okay, so in y2, here's what it's going to look like if you have an old operating system. Let's look at the picture and see if that's right. It's n derived, and then you're going to put in y1, comma x, but you're not going to do it at just one point. You're going to do it at all of them. The calculator numerically is calculating the slopes at all those points on the line. It will look different on the new system. Okay, so where is my calculator? Oh, because I'll have to get it out again. I thought it was out. I probably closed it. I like that one better, but that's okay. And I already have mine set up. Now, when you are working with trigonometry, you have to always be in radian mode. So, y equals, I'm going to just clear it. Yes, you do. Clear it. Okay, so I'm going to press mode.
That's for first.
You're always in radian mode in calculus. In physics, you're in degree mode, but not in calculus. So you're going to have a problem if you don't switch. So the day before the exam, we're going to switch our calculators. The day of the exam, we'll come in and remind you again to switch. Okay, so in y1, I'm going to put in the sine function. Okay, in y2, I want that n derived. Do you guys remember where that is? Math. This little arrow here by 7 says, there's more. Except I pressed the button too many times. Okay, n derived, and I'm going to get the pretty print. I'm not going to get what I just showed you. Oh, I don't want these buttons. I want a large screen. Okay, this is an x. Hey guys, this is my, whoops, I want my function. I could type in sine of x, or I could go into variables, and there is a shortcut keys. It's alpha trace. For those who have it, it's always a y variable. We'll never use the other stuff. And I want y1. And then I'm going to go over, and I want to do this at every single x value. So don't put a number in, but put in x. And on the left side, if I arrow over here, see I have a little 0 with a dash? This is going to leave me a circle trace. So you're going to see the circle, but it's going to leave the trace of the function. And you just press enter until you get to that. I'm going to press graph. Oh, and because it's trig, I zoom trig. And there comes the sine function. And here comes the cosine. It does because it's doing it numerically. Could you find the derivative again of the cosine?
Would it be sine? Negative sine.
Negative sine. That's good. Yes, it is.
Oh my
It looks like the whole algorithm wrote down.
And we can see if it makes sense. Let's take this picture. Okay, guys? Here is the sine function, right? And let's just check it real quickly. What's true about the slope of the sine function at pi over 2? There it is, it's 0. And all these slopes from here up to the top are positive, so my cosine, those are all positive values. So our calculator can actually give us the graphs. You could try it with some other things. When you do the activity tomorrow, though, you're not going to use your calculator. You're just going to look at them, and you're going to do some sketching and see what you figure out. No. We have an activity tomorrow and work time. Okay. Let's try to graph a function if we know what its derivative is. So on the left side, this is f prime of x, and this is f of x. We'll do a lot more of this later on. Now remember, what's f prime? It's a what? And what's f prime? It's a what? It's a slope. So what this graph is saying, my function's slope is constant at -1, provided that x is less than 1. Talk about the open circles in a second. And it's 3 when x is greater than 1. So if the slope, I'm going to write its slope, is -1, then what does that graph look like? Negative x. What's the slope of y equals negative x? -1. Okay, so we're going to start at 0, 0, and I want to go through a line through 0, 0 that has a constant slope of -1. Does that make sense? And then I'm going to stop where? No. I'm going to stop at 1. It's going to include that point because it says my function is continuous. And then I need a line. I have a slope of, what's the next slope? 3. So that would be like y equals 3x. And these guys are shifted, keep in mind. I'm going to go over 1, up 3. Over 1, up 3. And there's your graph. Is that okay? Because the derivative has open circles here. Make them big. Because what can you say about the slope at this corner? It doesn't exist. Right? How can you give me a single value for the slope? You can't. If you're driving your car, it's the same as going backwards and not stopping. It's shifting in forward. That's a very bad thing. Derivatives have to come around smoothly. So even though this is a continuous function, it's not differentiable here. Derivative does not exist. So you probably have some problems that look like this. There'll be constant slopes. They have to be because we don't know how to do anything else. Okay, one-sided derivatives. And we're going to cheat a little bit. But when you look at a derivative, you really should look at it from the left and from the right. Okay, guys? For a function to be differentiable, the left derivative has to equal the right derivative. So let's look at my function right here, Grant. And let's look at y prime. Now I know the derivative for x greater than 0, right? What's the slope of y equals 2x? 2. That's something new, right? Now I know some of you have an idea what the derivative of x squared is.
This thing is good.
Anybody know?
It's X.
No?
That was bad.
No, it's close. It's 2x.
Yeah, Josh.
Okay, I don't want to go through the derivative process.
Remember how we did that sale? I can't remember.
2x. 2c. Okay, now, the derivative is fine everywhere. The only place in question is at 0. So what's f prime of 0 from the left, and what's f prime of 0 from the right? Well, the right's the easy one. What's the slope from the right? 2. What's the slope from the left? Well, left of 0 is 2 times 0, which is 0. Does the derivative exist there? The left derivative has to equal the right derivative. And let's look at what this looks like. Y equals x squared looks like a parabola. And at the bottom, what's the slope at the bottom of your parabola? It's 0. And then the other one is y equals 2x, which is a slope of 2. Do you see why it doesn't exist here? Because we have a cusp. Anytime your function takes a sharp turn, you have a problem. It's not differentiable. Because the left derivative does not equal the right derivative.
That's because 2x is not.
At x equals 0, because we're talking about the slope, what's the slope at the bottom of your parabola? It's 0, isn't it? So this is 0, that's 2, and it has to transition nicely. There's no way around it. Is that okay? Yes.
So like the y, the little thing, that's the slope.
The y prime, this is the slope. Okay? And one last note. Does a function have to be continuous to be differentiable? Grant.
Yes.
Does a function have to be continuous? Yeah, because you can't take a derivative at a point that doesn't exist. What if the function is continuous at that point? Does it have to be differentiable? No. Can you give me an easy example? Absolute value of it. There it is. Just because it's continuous doesn't mean it's differentiable. But if it's differentiable, you know it's continuous. Don't see any more slides. Now, are there questions on homework out of 2-4?
Yep.
Which ones? You have no questions? You're going to come up and do them?
He's the one that's got the question.
Then you can do that.
Wait, give me a prop and I'll solve it.
I always like to look at the pictures. Except when I don't have a pen. Hey guys, what does this look like? 1 over x minus 1.
Oh, it's a parabola, like there's the non-parabola thing that goes like this.
It's hyperbola,
Yeah.
and it's shifted over 1 unit. Okay. I want to find the equation of the tangent lines where we have a slope of -1. So the slope's going to look something like this. Looks like there's 2 of them. You didn't give me the x value. I need to figure that out. Okay, ready? We have to find the derivative of this. So it's the limit as h goes to 0, It's f of c plus h minus f of c. I don't have the x value. Doesn't look like fun. It doesn't bother me, it might bother you.
Then you plug in.
So it's the limit as h goes to 0, so it's 1 over in place of x. Okay, you guys, if you got it, you should be working on something else.
C plus C minus 1. Then you multiply that times C plus H minus 1 times C minus 1.
Okay,
Over C.
Natalie, you got that? Because it's f of c plus h, so in place of x, I'm going to put in c plus h. Then I'm going to put in c. Grant says we have to clear out those fractions. So I'm going to slide this over. And I'm going to multiply by a product of those denominators.
Why is it 1 minus 1 over c minus 1?
Because what's f of c?
2x is 1 over x minus 1, so C is 1 over C minus 1.
So you're just replacing that c in...
I'm replacing x with c.
Alright.
So we're going to multiply by c plus h minus 1 times c minus 1. Now you've got to be fair. You can't just do that with the numerator. You have to do it with the denominator of the big fraction, not the little one, or you get confused. Okay. Because what's the x value? Now you distribute that, and I pick the denominators nicely so that, or the multiple here, so I don't have to have those fractions.
C minus 1 minus C plus H minus 1.
C minus 1 minus C plus H minus 1. Do I need those parentheses? Yes. And then in the denominator, I know you want to multiply them out, but don't. Honestly, I don't even want to multiply them out. Can I cancel the C plus H minus 1s?
No.
No. This tells you what to do. You have to simplify that. You have to have a multiplication problem here. I don't have a multiplication problem. But remember, I promised you that things would cancel. It's minus C minus H plus 1. So it's not as bad as it looks. What happens to the C's? C's cancel out. What happens to the 1s? Don't lose that negative sign with that H. So if I factor out, I don't even have to factor anything. Grant, shh. Maybe we'll put Cole back in the back of the classroom again. What's going to happen to the H's? You should be doing it with me. It's a homework problem.
See, I did it. That's, I don't need to do one.
Do a different one.
I could have done this from the beginning.
Now for the calculus, let H go to 0, so that's going to be 0. That's it. So it's negative 1 over C minus 1 times C minus 1. Or negative 1 over C minus 1 squared. Okay, I was just finding the derivative. We haven't done the problem yet. It says I need to figure out the C value, so the slope is equal to negative 1, correct? So slope is negative 1 right here. I need to find where does that occur. I'm going to guess it's at 1 and negative 1, but let's find out for sure. So I want negative 1 is equal to negative 1 over C minus 1 squared. Question. It says the slope is negative 1. This is the slope. So I have to set them equal and figure out what the C is. What's going to happen to the two negatives? What's going to happen to the two negatives? Cancel out. Cross multiplying, I get C minus 1 squared equals what? 1. Now, I'm going to do this the way you... No, because what happens to the two negatives? If you want to put a negative in here and a negative there, you may, but then I'm going to get rid of them anyway. Now, I should square that out and get everything on the left side, or, because this is a perfect square, I can square it both sides. And what's the square root of 1? 1. What's the square root of C minus 1 squared? No, it isn't. It's absolute value of C minus 1. Because because square roots have to always be positive. What if C is 0? If you say it's C minus 1 and C is 0, you're going to get a negative number. Square roots are always positive. You must always put them into absolute value. And then with this absolute value equation, C minus 1 is equal to 1, or C minus 1 is equal to negative 1. So what's this equal to? C is equal to what? 2. I guess was wrong. Or C is equal to 0. Oh, because it's shifted. I forgot it was shifted. And that's what it's asking for.
Oh.
So this is at 2. What's the y value there? What's the y coordinate? It's 1 over 2 minus 1. So it's what? 1. This is at 0. What's the y value there? It's 1 over negative 1, so it's negative 1. What are the equations of your tangent lines? Make sure you answer the question, Adam, because that's the problem on the exam. A lot of times students do not answer the question. It's very frustrating grading that. It's y minus 1 equals my slope, negative 1, x minus 2. This one is y plus 1 equals negative 1, x minus 0. Done. Now, if they want the normal, I'm trying to understand if that's the normal, that slope of the normal is 1. It wasn't real clear to me when I read it. Find the equation of each normal to the curve that has a slope of 1.
What's a normal?
It's the perpendicular. It's this. It's the same place. So it's y minus 1 equals, well, if this is slope of negative 1, what's its normal? 1. And it's x minus 2. Same equation here is y minus a negative 1, or y plus 1, equals 1, and it's x minus 0. Oops, sorry. Yes?
When you cross off the
H is 0. Okay? So tomorrow you're going to have an activity to work on and you have time to work on your homework. Please use your time. I know you have tons of things to do.